Now let's talk about something called a variable resistor, and you need to know this for the exam. You need to be able to explain it as well as show the calculation behind it. Now the actual variable resistor looks like this, or it looks like this. This is a sliding variable resistor. And what variable resistor essentially is a resistor that you can control the resistance. Okay? Remember the resistor that I showed you? It looked like this before, right? In B5.5. These guys are fixed values. So if I want to change the resistance, I need to swap out in a circuit. But what if I didn't need to do that? That's the variable resistor for. Okay, so how does this principle work? I'm going to explain it briefly. You're never going to get tested on how they actually work, but I think it's really fascinating to see. So if I lift this cover out, this is what it looks like on the inside. You have something called a wiper, which can go around, and you have this metallic resistive material. Okay, and what's going on is, well, you're going to connect here with, a power source, positive, minus, and you're going to have maybe like a lamp. Whatever, right? And connect that here. Boom, okay? So how this works is by literally just turning this, I'm actually able to control the brightness of the lamp. That's actually what it's being used in your room, right? Right now, if I want to change the brightness of the room's light, that's what in the switch, there's a variable resistor in the switch. Okay, and what happens? Well, if I, let's say, bring this over to here. Okay, so now it's here. Okay, what's going on? So I'm connected like this, right? The wiper is going to move with it. So what's going on? Well, in terms of circuit, it's connected now like this, right? And remember, with the length of the resistor, the resistance changes. The longer the length, the higher the resistance. So I can actually make the resistance of the circuit change, therefore changing the current of the entire circuit. And by changing the current of the entire circuit, I can control the brightness of the lamp. Same thing, if I make it, let's say I bring it this side. So now I have it here. Okay, what happens? Well, now the power source is going to go through this entire resistive material. So I'm making it longer and making the resistance higher. If I make the resistance higher, I'm going to be decreasing the total current. So that's actually going to dim the light, right? So that's how it actually works. Okay? Now, this whole variable resistor thing, you actually need to be able to quantify in calculation. So I'm gonna take you through this one example problem. It's a little bit tricky, but stay with me. One tricky problem, and hopefully you can figure this one out. Okay, so if you want, pause the video and give this one a try. By the way, this you can find in the textbook. Okay, so to briefly explain, this component is being investigated, and this is the variable resistor. By sliding this is actually the sliding variable resistor. By sliding this arrow to either here or here, you can actually control, what's going on in the circuit and change the resistance accordingly. Okay, so let's see. At the top, if the thing was connected, let me erase this. If the thing was connected at the top, what's going on? Well, let's see what's going on. So the current goes like this and also like this. Essentially, they're in parallel circuit, so it looks like. Essentially like that, right? Because I'm connecting it to the top. So they're essentially in just a parallel circuit. So you can determine the potential difference across the component. Well, that's just going to have the same as this guy, 12 volts. So both of them are going to experience 12 volts. Okay, so the answer to A is 12 volts. What if I put it at the bottom? What's going to happen? Well, let's visualize this. If I put it now at the bottom, so let me put this at the bottom. Right? Okay, let's take a look in terms of the whole circuit. So what's going on? Well, it's going to actually go through like this only. It's not even going to bother going through like this, because why would the electron take an extra step to go through this and then go back on track when it can just go through zero or very low resistance and metal here and just go through, right? So actually, this is going to experience 0 voltage. It's not even going to experience any current in it. And so this is going to have 12 volts and 0 volts. So that's actually 0 volts. So by the way, if you didn't know from before, like that's how it would look like, right? The electrons won't even bother going through this. It will just go through like this. Okay? Now part C, what if it's at the midpoint? Essentially what's going on in the circuit, if I were to draw it, it's as if I divided this resistor into two, and I brought it in the middle. So it's actually going to be parallel with this guy and this, resistance with this. And so if you put it actually halfway, it's going to split the resistance equally. Okay, so remember that the component being investigated has 24 ohms. This has 24 ohms. And this can go from 0 to 48. So if I were to divide it in the midpoint, it's going to have 24, 24, 24. So let's calculate the R total. R total is going to be this plus this, right? So the parallel component is going to be this, and the series component is going to be this. So that's just 12 plus 24, which is 36. Okay, and determine the PD across the component. Well, it's actually, you can do the full breakdown and calculate like usual, but it's actually going to be 24 over 36. You're going to learn that this is how the proportionality works. So it's going to have times it by 12 volts. It's actually going to come out to 8 volts. So this guy's going to experience 8 volts, and this guy's actually going to experience 4 volts. Okay? You can do the whole, find the total current and then find the individual voltage across this guy, and then minus it and find this guy if you want. Okay, but you're going to get the same thing as this. Okay, so we're actually going to end it here for topic B5. I hope this was useful. If you're still confused, and roll back and rewatch some of the videos I've posted. We're going to dive into topic C next for IB physics. But beforehand, I might actually do practice problems on topic B in general, past paper problems for topic B. So if that kind of content interests you, then just leave it down below in the comments so I know which topic you want me to cover in past paper problems. Okay? Until then, I'll see you in the next video. Hey guys, thanks for watching. If you like this kind of video, then consider giving us a like and subscribing to our channel. We have a lot more lecture style video and content like this in our channel, so feel free to go check it out. If you're looking for additional guidances like one-on-one tutors in IB subjects, SAT, TOK essay, IAs, writing, etc., then go to our website at NovaEdgeAcademics.com, fill out the form, and get in touch with us. In the meantime, we'll see you in the next video.